As we continue our discussion for this module on labor demand elasticity, we will now take a look at the midpoint formula, which you'll recall is one of the two formulas I indicated along with the simple formula can be used to calculate elasticities. In this case, labor demand elasticities, but this can be used to calculate for any type of elasticity, as can the simple formula. So the midpoint formula is going to be a little bit different. The midpoint formula is, rather than simply take the percentage change, traditional percentage change formula, we're actually going, which takes the change and divides it by the original point, we're actually going to take the change and divide it by the average between the starting point and the ending point, which will tell us something a little bit different about the curve that we're looking at than the simple formula will. Let's first look at the formula, and then let's look at what it might be telling us in terms of the curves that we're looking at in the XY space, and then we'll take a look at a couple of examples. So first, let's consider the midpoint formula as a formula. So we're looking still at L2 minus L1 divided by L2 plus L1. We'll sum that value and divide that by 2. So this becomes a little bit more complicated. And now once again, we have W2 minus W1, and that is divided by W2 plus W1 divided by 2. So we have the same numerators in each of these parts of the equation, but rather than using the starting point as our denominator, we're using an average between the starting and ending point as the denominators. And that is our our midpoint formula. Well, what's it telling us? Let's think first about what we would be seeing if we're looking at a linear relationship, like we might be looking at if we have a labor demand curve such as labor demand equaling 60 minus 3W. And we've used this demand relationship before. So if this is a linear relationship, so a straight line, then the midpoint formula is giving us some understanding of the slope of that line. If we have W2 and W1, L2 and L1, and L and W, the midpoint formula really is giving us some understanding of the slope between these 2 points. Well, that's fine on a linear relationship. That really is no different at any point. The slope at any point on this line is the exact same slope. But what if this is not a linear relationship? What if it's some decreasing demand curve at a decreasing rate? Well, let's look at this. So a decreasing demand curve at a decreasing rate might look something like that. We still have wage. We still have labor. And let's assume we had some W2, which motivated some L2, and some W1, which motivates some L1. Well, in this case, we're now looking at not only a differently sloped curve, but it's a curve really instead of a straight line. And the midpoint formula is going to give us some understanding of the curve between these 2 points. In fact, it essentially gives us an understanding of the slope of the line that we might connect those 2 points with. Well, that was the same thing happening over here in the linear relationship, but this was a linear line curve to begin with. This one is no longer the straight line. So now let's think about an example. Let's consider where we have some initial level of wage. Let's say that initial level is W1 equaling 8, and we're going to move to some W2 equaling 10. And that then is going to let us think about the L1 and L2. But now let's use this labor demand equation that I've noted here. Labor demand equals 60 minus 3W. And so if we want to use that equation, we can plug this into either the simple or the midpoint formula, and we're going to, for comparison's sake here in a moment. then we can see if there are any differences. Then let's think about this. If we have a wage of 8, then labor will be 60 minus 3 times 8, or 60 minus 24, so it should then give us 36. And a wage of 10 will give us a L1 of 30. Well, first let's plug this into the simple formula and see what it gives us in terms of a elasticity. So this is going to look like 36 minus 30, 36, not 63, 36 minus 30, and I've done that backwards even, excuse me. This is going to give us 30 minus 36, L2 minus L1, divided by 30 plus 36, divided by 2. And then we'll look at the wage, W2, W1, so 10 minus 8 divided by 10 plus 8 divided by 2. And I see that what I'm actually giving you at the moment isn't the simple formula. I'm giving you the midpoint formula, so let me correct that, because I really do want to keep these separate. This should have been 36, and this should be 8, which would then let us see some negative 6 divided by 36, and that divided by 2 divided by 8, or the way that I might prefer to look at this, negative 6 over 36 times 8 over 2, or I believe this is going to be negative 48 divided by 72, which will equal negative 0.66, or we would recognize that that is inelastic. Well, let's use these same values and plug this into the midpoint formula and see if we receive any different value here. So now we'll look at 30 minus 36 divided by 30 plus 36 divided by 2. And then 10 minus 8 divided by 10 plus 8, and then the sum of that divided by 2. So we still have the same negative 6, but now we have 30 plus 36, or 66 divided by 2, and that's now going to be 33. And we'll have that over 2 divided by 10 plus 8 is 18, divided by 2 is 9. So we're looking at negative 6 over 33 times 9 over 2. Well, that's negative 54 divided by 66, which is now no longer negative 0.66, but it is still negative 0. And I believe we're looking at 81 if we calculate this. So in each case, we see it's inelastic, and we see that the numbers are only slightly different. They're still very inelastic. Now, why do we have this difference? Because the midpoint formula is more accurate, and the greater the change in wage, or the greater the change in price, the greater the distortion in inaccuracy of the simple formula, the greater the difference or change for accuracy for the midpoint formula. Let's see if we can look at a different example that actually causes us to see a much larger change in this, one that would make a significant difference to us in terms of how we interpret these values. Let's once again think about, we'll use both the simple and the midpoint formula once again, but now we're going to look at a different type of wage change. We won't use this equation that we began with. We'll use now a different equation. We'll just come up with some different values. And let's assume that we have an L1 equal to 36, an L2 equal to 12, a W1 of 8, and a W2 of 16. Well, with this, let's plug this into the simple formula. So we then have 12 minus 36 divided by 36 over 16 minus 8 divided by 8, we know that's going to then give us negative 24 divided by 36 and 8 divided by 8, which simply is 1. So this value, the numerator divided by 1, is simply going to be the numerator. So negative 24 over 36 is once again going to be negative 0.66. And you'll notice I didn't extend this to the next level of calculation, because when we have a value divided by 1, and 8 over 8 is 1, then the value simply is the value. Dividing it by 1 doesn't change it. So let's look at this differently, and let's give it see what its value in a midpoint formula would be. I would expect that since we have a fairly significant change in price here, or wage, going from 8, doubling that to 16, that we would see an even greater difference between the simple equation's output and the midpoint equation or formula's output. But let's see if that actually works. So let's look at this. We have 12 minus 36 divided by 12 plus 36, and then the sum of that divided by 2, and then we'll take 16 minus 8 divided by 16 plus 8, and then the sum of that divided by 2. Well, we continue to have then a negative 24, but now 12 and 36 is 48 divided by 2. Well, now we have 24. And we have then, similarly, the 8 that we had in the other equation, but 16 plus 8 is 24, divided by 2 is 12. This becomes a little bit less obvious to us, so let's actually do it the way that I most often do when I'm doing simple math by hand. And let's just multiply this by inverting the denominator. And when we do that, we see what we end up with is negative 288 divided by 192, which is now 1.5, negative 1.5. Well, we were inelastic when we used the simple equation, but now using the midpoint formula, we see that we actually get a value that is elastic. And once again, we know that the midpoint formula gave us a more accurate output, which output is not terribly different when the change in wage is small, say less than 10%, but then in this case, the change in wage is 100%. And so the midpoint formula gives us a much more accurate output.